Okay, so what we didn't do is one thing is this, that the summation of GP series. That means T1 plus T2 dot Tn when it's GP. That means A1 plus A1R plus dot A1R to the power n minus 1. So if you sum it, you write summation like this. You go from I from 0 to n minus 1. It's A1 R to the power I, right? So this is what the GP series is all about. That this is a series because the sum of sum is called a series. And if you take A1 common, you get this GP series. And again, you can do the same thing, but in a different fashion. So let's see. We will again use Gauss sum method. So we are with A1, A1R, A2R, dot A1R minus 1. Now we cannot do what we cannot do like addition, reflection. No. Now we have to see that what stays constant and what doesn't stay constant. So if this is S, let's say, you have to see that doing a small change, what doesn't change. That's a very important property. It's called the invariance principle. You have to see doing one small change, what doesn't change much. Okay. So if you multiply by R, you see that the A1 becomes this becomes A1R square, and this becomes A1R cube, which is here. So essentially you see that we are trying to see what doesn't change much. This is very important problem solving strategy. I'm repeating over and over again so that you understand. And everything will be here, like essentially you can see that in top, these are coming out to be like this. Similarly for here, this will turn out to be the A and R to the power A1 R to the power n minus 2 will turn out to be this, but this will turn out to be A1 R to the power n. So when you subtract this right now, if you subtract S with S minus R, so you get S into 1 minus R, you get this cancelled, and on the left you are at A1, and here it's minus, so it's minus of A1 R to the power n. So essentially you're trying to find out what cancels out, what only those things cancel out that do not change, right? So that is what is called invariance. That invariance means that which, or something that doesn't vary. Okay. So A1 into 1 minus R to the power n is equal to S into 1 minus R. And you get that S is equal to A1 times. Okay. But again, we use the same principle as Gauss. See things that do not change. So this is one important problem solving strategy when you are having a sum of arithmetic geometric progression or a geometric progression. This is how you do it. As an exercise to this, let's try something more interesting. This is called arithmetic geometric progression. What is that? AGP. It starts with A1. Let's call it A now. A. The next one is not AR, but twice AR. The next one is not AR square. I'm doing it right. Yeah, twice AR square. Just let me check once. Yes. Okay. Now, where did this come from? Let me give you a better motivation from a recurrence relation point of view. Start again. This is an important topic actually. AGP, arithmetic geometric progression. So the basic idea is simple. In GP, you had A1 is equal to AN is equal to AN minus 1 times R, right? This was your GP. In AP, you had AN is equal to AN minus 1 plus D, right? And both starts with, let's say, A1 is equal to A in both. This was a recurrence relationship. So how to combine them? AN is equal to AN minus 1 times R plus D. That means at the same time you are multiplying and you are keep on adding. See the point? You're multiplying and keep on adding that. Like there's a principal interest rate and D is the regular addition of money that you have. So in finance, this equation is really important. In LIC, if you have seen your fathers or your parents doing, then I learned it from my father. So essentially every year or every 6 months, let's say you do a HDFC Life LIC insurance. So every 6 months you give in a constant amount of money, D, and at a certain rate, every month it correspondingly increases, right? Every 6 months, let's say it has a certain interest rate. In that case, essentially it's AN is equal to AN minus 1 times RN, because the rate increase is different every single year, but the constant. So you see this equations actually come up mostly in time series in finance. Okay, it's very interesting. So if you're interested in finance after this, please feel free to read about all of this. A very good book will be An Introduction to Mathematical Finance. You can understand this by Sheldon Ross. That's a very good book to start with. And you will see a lot of sequence and series there like this. Okay. Okay. So this is AGP. Now, how to find the equation? So we have found out the Rn, the recurrence relation. Now you have to find out the A, the analytical form. Okay. So how do you find analytical form? What's the idea? So it will be we will do the same thing, right? Uh, we will do the same thing. But this is an interesting problem, so I will do it using this. So let's okay. If you see in the AGP, we multiplied, right? So what we'll do is we will again multiply here so that it cancels out here. Okay, so this becomes this plus dr. So here we will multiply r square. It becomes this. And it continues. Okay. And again it will be r cube an minus 3 plus r to the power 4n minus 4 plus dr cube. And till what will it continue? It will continue only till a1 here, right? And what will be the dr to the powers? This is what we need to find. What will be here and what will be a2 here and what will be here. These are the three things we need to find, right? It's very easy. It's we are starting from n minus 1, sorry, n to a2, right? Here it was 1 r. So if you see that 1 plus n, so essentially it will be, if you see how to understand how to get those patterns, you see here it's 1, here it's n. 1 is nothing but r to the power 0. So you see pattern, always look for patterns. 0 n. Here it's 1, so 1 n minus 1, 2 n minus 2, 3 n minus 3. Okay, here also n minus 1 r to the power 1, n minus 2 r. This is how you look for patterns. Let's say here it's easy here. You will see. So it's r to the power 0, r to the power 1, and how many steps are there? A2 to an means n minus 1 steps, because n minus 2 plus 1, right? So here if it's 0, it should turn out to be n minus 1. Am I right? Yeah. Here also it will be, am I right? Just give me a minute. So let's do it here. Here you see that r to the power n minus 2, because the sum is always n, right? Here it's a1, but it's again, and it gets 1 added here, so it will be r to the power n minus 1. If you see it's 1 added here, and you can see the r0 is same, so it will also be r to the power n minus 2. So we get, you see how we discovered the pattern, guys? This is important to know for problem solving. All of you understood that? So all of you understood that, yes or no? So r to the power n minus 2 times a2 is equal to r to the power n minus 1. Okay, so the left side will not matter actually, because you can see why did we do this? When we added this should cancel. The telescopic again everything should get cancelled, right? So only this one will stay, this one will stay, and the sum will stay. So what do we get here? We get an times an r to the power 0 is 1 is, and then you get a1 is the starting point, r to the power n minus 1 plus d into, now you get the sum. So, yeah, right? So now you can find out, right? So this is a1 r to the power n minus 1 plus d times r to the power n minus 1 minus 1 by r minus 1. That's what we found out, right? This geometric sum.